Hi, I'm Larry, W6WUH in California. Here we get typical SB-102, and it's, this is 1968, 1970 radio, 72, whatever it is, 50 years old anyway. And eventually, the owner of these things is going to develop AGC problems, and you're going to want to fix it. Well, I've had this radio 20 years, and I can't just look in there and to tell you right away, well, where are the AGC components? Where are the resistors and capacitors that set the time constant for the AGC circuit? And where are the RF amplifier and IF amplifier tubes and the mixer tubes that the AVC circuit works on? Well, I'm going to show you how to find out right now. First thing you're going to do is get out your manual. And the great thing about Heathkits is that they have such great documentation. And you're going to go to page 151 and page 152. And you're going to read the description of the AGC circuit. And you're going to look at the AGC rectifier and read this and understand what it tells you. And what it tells you is that AVC voltage is applied to the RF amplifier and the first mixer. And it's also applied to two stages of IF amplifier. So it's V11, V10, V3, and V4. And there's a 6B and 8. There's two half-wave rectifiers that are 1/3 of the 6B and 8 tube, and a couple of diodes. The AVC circuit, this thing will tell you, is composed of negative bias that comes off of the RF gain control, and that's combined with variable negative bias that comes from this AVC rectifier. And there's two diodes that act as gates that allow these two voltages to combine without interacting with each other, so that the voltages don't go backwards. The next thing you're going to do is look at page 159 and whatever this other page is. It's the layout, the physical layout of the IF circuit board and the RF driver circuit board. And the RF driver for the transmitter is also the RF amplifier, the front end of the receiver. And in this description, on pages, 151 and 152, it's going to tell you exactly what each of the components in this RF amplifier circuit are. And it's going to tell you what they do. There's a fast attack AVC resistor capacitor combination, and that time constant of that capacitor and resistor make for the fast attack AVC. And there's another pair that's the slow release. A fast attack slow release is the kind of AVC that this has. There's another resistor capacitor pair that are responsible for that. And there's a little voltage divider, and there's some bypass capacitors and a couple of other little resistors in here. So what you're going to do is you're going to take your manual and you're going to go to a copier. I did it on my printer at home. And you're going to copy the layout for the IF circuit board and the RF driver board. You're going to make a list using that text on 151 and 52, you're going to make a list of the resistors and the capacitors that are in part of the AVC circuit. And then you're going to just take a highlighter like I did and go and find those various resistors and capacitors on these two different boards. And it's a little bit of fun trying to find out where they're actually physically located. But you got to do it. With this, you can take this chart now and go in and here's the RF driver board right here, and find these components right over here. And you can take this one and go to the IF board and find these components, and here they are right over here. So then the next thing you're going to do, if you've written down all the values for all of these, write down all the values for all of these components on these Xerox pages you made. And then you're going to go with your ohm meter, and you're going to measure the resistance of all these resistors and find out which ones have aged. And if they've wandered off the reservation, they're worse than about 10% or so, you're going to replace them. And probably the capacitors that we know are part of the slow and fast AVC circuit, we'll probably just replace them with new ones. By the time, the only way to check them for value, it's very difficult to check them accurately for value. The only way to do it is unsolder them from the board anyway. Well, you might as well check a brand new and make sure it's okay and solder it back in place. So that's the basic routine. Now, it took me a day or two to figure out what I was going to do. The other thing I did is I went in and this is a copy of a manual. This is not an original manual, but if you don't have a copy of a manual that you use as a workshop copy, do this again and make Xerox copies of these schematics. And then take your highlighter and trace out the AVC circuit. It's not hard to do. The AVC voltage is a negative voltage, and it always goes to the grids of tubes. And so it's always going to be a negative grid voltage going to the grids of these tubes, the IF amplifiers, the RF amplifier, and the first mixer. And right on the schematics there, it'll say 2 AVC. Often that means what it is a voltage from the AVC. But just take your highlighter and trace out the route from the AVC up to the grid and all the components that flows through. And that will help you understand exactly what each component is and what it does, and how important it might be. Whether or not it's part of an RC pair that sets the AVC timing, or part of the bias circuit, or whether it's just a little bypass capacitor. The negative voltage on the grids of these tubes sets the point of operation for the tube and the amplification factor. So it's very important that all of these resistors in the grid circuit, they're all part of the bias circuit for the grid of the tube, and it's very important that those things not be very far off of their designated value. 10% is okay, 20% not. So nowadays we've got good 1% to 5% resistors, and so what's the point of having something that's wildly off? Now there's something else to be considered. There's a couple of other known problems with the AVC circuit in the SB and hot water series of transceivers. And one of them has to do with internal fault in the tube that you really can't check with the tube tester. It's secondary emission, where electrons are bouncing off of the screen back onto the grid of the tube and driving the grid positive. And the grid has to stay negative for the tube to operate properly. And you can't test that on a tube tester, so the only way you're going to test that is to hook the radio up to a power supply, fire it up, get out your VTVM or a good digital voltmeter, and measure the grid voltage and make sure it's not going positive. There's a voltage chart in your manual, and you want to use that to give you a range of values. But you should be able to see a variable negative voltage on the grid as you adjust the RF gain control. If you hook an antenna up to it and tune across a strong signal, you should see the AVC kick in and it go more negative, and it give you some idea that it's working. You can go right to your schematic and check the negative voltage right where it comes out of this V13A, the AVC rectifier, and there's a diode there, D101, and you can check the AVC voltage coming out of that AVC rectifier right there, and you can check the RF gain voltage at D905 if you can find the thing, but you can find R14 and C13. They're on they're on the RF driver circuit board, and that D905 connects right to those, so you can measure it there. And so very quickly you can find out if those basic things are working, and you can locate a malfunctioning tube by measuring the grid voltage of each of these 4 tubes and see if you find a tube that's wonky even though it's tested okay. That's certainly the case in my radio. I've tested all my tubes with a good Heatkit tube tester, and I'm still having AVC problems. There's one other issue that I've read about that's in the Heathkit service notes, and I'll put a link here where you can go and read all of those Heathkit service notes. There's an issue where remember that the IF amplifier section and the RF driver section do double duty. They work both in receive and transmit mode, and there's an isolation stage that's supposed to isolate the final amplifiers and driver from the RF driver stage. But apparently the 6146s, they remove the screen voltage from the 6146s in the receive mode, but they don't ground them. They don't go to zero. They float. And apparently there's a small amount of voltage that's being fed back in some radios, being fed back into the IF amplifier board, which is desensitizing the receiver and also making the AVC go wonky. And so there's a Heathkit service bulletin where they show you how to take the screens of the 6146 final amplifier tubes and run them to a contact on a spare contact in the push-to-talk relay and ground them in receive. So that's a cure for a known problem that would be otherwise extremely difficult to figure out. I never in my lifetime would have ever discovered that, and I wouldn't have been able to do it through logic, and I wouldn't have been smart enough to look for it and test for it. But other guys who are smarter finally figured this out. Of course, these radios have been in the field now for 50, 60, 70 years, and a lot of smart guys have worked on them, including guys at Heathkit and a lot of techs in the field. And they developed this this modification, this service bulletin to cure this problem. So that's the last thing we'll do on this. We'll do all the other things that one would normally do And all of these things that we're doing here with this transceiver are really things that you do with any receiver that has AVC that's not working properly. You just go and check all the component values in the AVC circuit, figure out how it works, check the component values, replace bad components, and expect the SB to work. So we're going to do that, and if it still won't work, we'll do these other things. Okay. V13, V4, V3. There they are. V13, V4, V3. And of course, it's just your luck that these time constant resistors and capacitors are right down here underneath this stinking lamp. So, you know, luck of the draw, but the lamp's easy to remove. And anyway, here's the RF driver board, and here it is right over here. So there's your other parts right there. There they are. So makes it pretty easy. Okay, we've used our digital multimeter and we've measured the values of the resistors in the RF driver board and the IF circuit board. And most of the resistors are pretty close, but this one resistor is supposed to be a 3.3 meg, is a 2.2 meg. So that's 33 1/3. It's 1 whole meg off. So it's 1/3 lower than it ought to be. And guess where that is? That's R416. And here's R416. Here's the output of the AVC amplifier, comes through this diode, goes up to this voltage divider, and then it goes to the grids of the IF amplifier. So there's R416, supposed to be developing a negative voltage to bias the grid of the IF amplifier, but the negative voltage is going to be low because the voltage drop is low because the resistor is a meg smaller than it's supposed to be. So there's a big red flag right there. We know that's bad. The other resistors are pretty close. 10% would be 47K, and it's off by 19K, so that's 5%. This is 14% off on the high side. This 1 meg one is 3%, very close. And this one, of course, we know is way off the reservation. Now, so that's the other ones are, let's see, R124 and R117. And they are, let's see what the values are here. That's off 1.13 meg, so that's off 13%. And this one is off, see, 10% would be 330, and this is off by 200. So that's within 10%. So that's good. But these, 124 and 117, are on the IF circuit board, and they are over here. I think that's them, isn't it? 100K and 100K. And those form a bias circuit, a big part of the bias circuit for the first IF amplifier. So one of those is off 14% and the other is off 17%. I say we change those because we want the bias point of that IF amplifier to be as close as we can get it. So those are suspect, and we'll change them because it's easy and cheap to do. The other ones are okay. So the good news is that we found some obvious culprits. We didn't find anything in the fast and slow. In terms of the resistors, we don't know about the capacitors. They're more likely to go bad, even though they're just ceramics, or at least wander off. But we did find things that will change the basic bias point of the IF amplifier and the first mixer RF amplifier, especially that one, the first stage. So let's get those things fixed and see what change that makes.